Hello, everybody. Good morning, good afternoon, good evening, depending on where you're located. My name is Shreyas. Today, we're going to talk about how we can make use of the current state-of-the-art integrations between metrics and traces to speed up and improve root cause of issues. Particularly, we're targeting the use case of comparison of good and bad requests to root cause issues. A quick background about myself. I'm a technical lead at Chronosphere, where we're building a hosted metrics and monitoring platform for large-scale, high-throughput use cases. I primarily focus on the applications of metrics and traces to solve different observability problems. Previously, before Chronosphere, I was in the observability team at Uber, working on the alerting platform there. The agenda for the talk today is kind of split up into three sections. We'll first go over kind of like the experience today in root causing issues with an initial intro about different observability signals. We'll follow that up on basically go on a journey talking about deep linking metrics and traces and how that can actually get us to tomorrow, which is kind of jumping from an alert to a request comparison. To start off with, let's talk about some observability signals of interest. The three primary signals we're interested in for today are kind of like metrics, logs, and traces. So jumping through each of these, metrics have basically been around for a long time. They're one of the most commonly used tools for observability. They're very structured. They're fast and efficient to aggregate both at query and collection time. They're efficient from a storage perspective as they store aggregate information. Which makes them a really good tool to kind of identify high-level issues, but you stop short of being able to debug issues in detail. So they're not very detailed on a per event basis, and you cannot see like request response information in detail. That's where logs and traces come in. We're going to focus mainly on the use of tracing in this talk, but I'm going to give you a quick overview on logs just for completeness. Logs are basically the other standard observability signal. They're widely used and they've been around for a long time. Fast log search has made it useful for basically search and root cause. They are structured sometimes, but sometimes they're not. The structured log is improved, like structured logging is improving with better libraries. But in general, like they have the full information about requests, even if they're not structured and like consistent across a full application, they can potentially be linked to other logs based on common tags like request IDs. Finally, we're going to talk about traces. Traces are useful for understanding and debugging microservices or different code paths within a monolith. They're very structured. They store context information about the whole like API calls being made. The instrumentation is normally implemented in libraries like RPC libraries or wherever there's a transfer of execution context. So this means the initial setup for the instrumentation requires a lot of planning and work. But once an application is instrumented using tracing, users only need to ensure to pass around appropriate request context. Unfortunately, traces become very verbose as they contain the full request response information, describing every network hop leading to storage costs, leading to high storage costs. So like we need some form of sampling to limit the costs of tracing. Sampling is a tough problem as you need to pick like what you want to store for the tracing information to be useful. There are many ways people do sampling, like head-based sampling and like tail-based, like adaptive sampling. But many of these end up like losing critical like events, especially for the ones which actually occur infrequently. Yeah, so moving on, I want to talk about like an on-call issue. An engineer gets woken up at the middle of the night. He gets an alert saying a particular endpoint is seeing higher latencies. So how does the engineer actually like walk through like debugging this issue? So the alert basically has some context information on it, whether it's an email or a page. That context information has pointers to Grafana graphs or some other visualization system. The first action may actually be to go visit the Grafana dashboard and try to see what's going wrong. Dashboard can have multiple graphs. The offending graph in this case is basically the request latency histogram graph, which is showing that some requests are taking much longer than others. This is what we actually need to investigate. There could be many reasons for this. It could be any of the dependencies being slow or just an issue in the application itself. Tracing could be useful here to resolve the issue. So the user probably wants to use traces or logs to debug further. Now, traces or logs need to be searched based off some tags, but the graphs themselves need to be easily readable. So to get to the actual tags on the metrics, you may need to go to a different view where now you get some tags on the metrics, which here kind of they're showing you the endpoint, the instance, the job, or some other information. Now, kind of armed with this tag information, we can use logs or traces for the root cause. For the current scenario, let's talk about using traces. This slide shows a Jaeger search view. Jaeger is a widely used CNCF project for distributed tracing. So once we have the tags, we can basically search for the appropriate traces using Jaeger. In this particular case, we probably also want to use the latency numbers from the metric to actually search for a target range, for a target trace within the latency range that we're interested in. So first, the user probably wants to find the trace with the higher latency. The trace kind of details the number of steps it's doing. There's an API call to dispatch a customer, which has to look up the customer. And that lookup has to go to Redis or MySQL. In the slow case, it seems like MySQL actually has taken quite a bit. Now, seeing this, you probably want to see what the lower latency trace actually did. So you basically kind of make another search to look up the lower latency trace. When you look at this, you see that the MySQL call doesn't exist. So it was probably MySQL having the problem. If you actually see a trace difference view, which Jaeger supports, like comparing both of these traces, especially useful in larger traces, then it's kind of clear that the culprit here is actually MySQL. And yeah, then you can kind of use that information to go further and root cause things further. So trace differences are really powerful tools to help root cause issues, but actually making use of trace differencing is not very easy. You need to be able to search for two traces with kind of specific characteristics, which in most cases is not a trivial task. Moreover, sometimes traces for rarer circumstances may not even be present. So the question is can we actually jump directly from this email that we got directly to a trace differencing view? In the current, with the current technology and Jaeger search, this is kind of difficult because metrics do not have a trace associated with them. But some work on deep linking metrics and traces that my colleague Rob Skillington presented at KubeCon San Diego last November actually makes this very feasible. We'll first kind of go over a summary of that work here before we talk about how we can leverage that work to basically make getting trace differences much easier. So moving on, talking about kind of deep linking metrics and traces, with this it's actually possible to associate a metric data point with a representative trace. So normally, as a recap, the way we did it earlier, how do we actually use metrics and traces together? The standard integration is to use kind of tags to map between metrics and traces. These tags need to be similar, or same, so that when you get alerted on something, you can actually take those tags and search for appropriate traces. And the other challenge is that even if you try to search for the traces may not be present due to sampling. Yeah, but kind of with the use of some of the latest OSS technologies, it's actually possible to jump to traces directly from metrics. A lot of this work is currently like work in progress, but it's possible to store the trace and span IDs alongside the metric data points, giving a way for us to go directly from a metric to a trace. We'll walk through kind of the different steps needed to make this possible. The first thing we want to talk about is kind of open metrics and exemplars. So open metrics is a standard for transmitting metrics at scale. One of the things it specifies is an extended Prometheus exposition format, which is essentially the Prometheus, like regular Prometheus exposition format. But in the comment section of the exposition format, you can like add different foreign keys and context information on a data point. For the purpose of kind of this exercise, we're going to make the trace ID the foreign key, so it allows us to kind of link to traces. Now, given this exposition format, we need a way to actually emit metrics with trace IDs, and that's where kind of OpenTelemetry comes into play. So OpenTelemetry is a new standard that provides a single set of APIs to emit metrics and tracing information. It allows essentially us to emit metrics along with kind of additional context information. This additional context information can come from the traces. It could be the trace ID, and OpenTelemetry supports the Open Metrics extended Prometheus format. Some of the below things we're going to talk about, and especially in the Prometheus and M3 phase, are still a work in progress, and we're having continuing discussions with stakeholders. So we've been working on like adding Prometheus support to scrape metrics with exemplars and kind of making them available to remote write customers. M3 now has the ability to actually store exemplars alongside metric data points. The exemplars, or essentially the trace IDs, are durable and stored for the lifetime of the data point. The one challenge here is that it does end up using a lot of extra memory. Depending on the length of this foreign key, the trace ID, it could be a few tens of bytes per data point. So we need to kind of limit the emission and storage of exemplars to just the specific metrics where the information is most useful. In this scenario, like especially when we kind of combine this with tracing, RPC metrics is one of the cases we're interested in. The query engine of M3 supports returning exemplars along with data points, and it also ensures representative exemplar to be present even after applying aggregation functions like sum and max and others. So one of the challenges with using traces for debugging these like corner cases is actually sampling. Traditional trace sampling techniques like head-based sampling or different adaptive sampling techniques are in many cases insufficient because these one-off traces don't get sampled. So we need to use some form of tail-based sampling to pick traces that were emitted as exemplars with metrics. So assuming we have a trace holding tier, which can cache all the traces for a short duration, with the M3 aggregation layer, then kind of indicating to it like which additional traces to persist. So traces basically, like the regular head-based sampling still applies, but we additionally go and like persist another like additional set of traces which the metrics are directly associated with. So what does this complete ingestion pipeline look like? You have an application instrumented using OpenTelemetry. It's using Open Metrics extended Prometheus format to emit those metrics. The metrics get scraped by Prometheus, go through the M3 aggregation tier to like long-term storage for the metric data point and trace ID. Traces go to the Jaeger collector, but instead of going are 100% sampled and go to the Jaeger collector, but instead of going directly into storage, they sit in a holding cache. And the holding cache basically gets information from the M3 aggregation tier to actually store the traces that are associated with metrics. Any regular sampling, like head-based sampling, can also can still happen, and those traces can also like end up in the trace storage. Finally, like different consumers like UIs, Grafana or Jaeger, and the alert engine can basically speak to the tracing and the metric system to actually like create like nicer user experiences. So you can basically end up with a Grafana graph, for example, where like because every metric data point is associated with a trace, you can make extensions or plugins where you can like click on a data point and kind of jump to a corresponding trace. So now, initially we showed kind of how trace differences can be valuable tools for debugging. The difficulty is actually in searching for these traces. Now, deep linking between metrics and traces actually makes the job of actually searching for these traces really trivial. So we plan to leverage that to build integrations that allow us to jump from a graph or an alert directly to a request comparison. I'm going to jump off to a demo, and we're basically going to talk about like what the on-call experience can actually look like. For the purpose of the demo, we're going to use a Jaeger example application called Hot Rod, which simulates different types of traces, request responses, so we can create like a few interesting traces. So jumping to Hot Rod. So we can kind of see Hot Rod running here. We've basically put some data into it, and Hot Rod's like sending requests. We had some alert emails come in previously. Now these emails are like regular alert emails, but they have some additional context with like a dashboard, which is common, but they also actually point to a trace difference. So if you actually click to the trace difference, we basically get back to the initial example we had, but we basically are able to get here in like one step. We'll talk about how that's possible a little later, but essentially this like automatically is showing you the difference between like what is a good and a bad trace. And you can actually see here that MySQL being present is the actual problem. We've also made some changes kind of through like a Grafana graph, has a number of different graphs. Here, like we can actually look at something like a 5xx, where now I want to see like why this error actually happened. And you're able to jump directly to another trace diff, and it kind of shows you the trace difference information. Let's look at another one. Yeah, so this trace difference is actually showing you that both these traces kind of took the same path, but the failing trace, like they missed the Redis cache, ends up kind of missing, like failing in MySQL and returns, but the successful trace actually succeeded MySQL and made kind of further forward progress. So these are kind of some of the integrations that we can actually set up. So I'm going to move back and kind of like jump back to the demo now. I'm going to jump back to the presentation now. So yeah, so how is it actually possible to actually to build these integrations? So we leveraged OpenTelemetry and OpenMetrics so that we can kind of emit the trace IDs as exemplars. We leverage Prometheus and M3's like support to scrape exemplars, to scrape and kind of store exemplars alongside the metric data points. But the critical part is we finally kind of like worked on building contextual links into the systems which are actually like consuming the metrics and the trace information. So these are essentially your alert engines, your Grafana, and other visualization tools. This is really possible because it's not really difficult to build these contextual links, as the underlying data is actually readily available. M3 query returns exemplars alongside metrics. It ensures a single representative exemplar, like if present, like across aggregation functions. And kind of using this information, it's possible to build contextual links into different query consumers. As can be seen here, like when the value comes back, there's a timestamp data point and there is a span and trace ID. So if you have something like this, this kind of shows another sample workflow we could build into graphing solutions, where you kind of click on a one metric and you mark that as your control trace, and which in general kind of can be your 2xx's, can be your control trace. And then if you have like 4xx, 5xx, and other like error information here, when you click on like the 5xx and you show a trace comparison, it'll like diff it against the control trace. So that's one idea of like how you could build contextual links for a graphing engine. You could, in general, just have the graphing engine say that this is a control metric. For alerting integrations, you could provide the ability to configure a metric that can act as a good source of good exemplars, source of like control exemplars. Another thing which is actually possible is to basically, like for standard well-named metrics, like RPC metrics, we can build plugins that can automatically detect and provide comparisons kind of based on knowledge of the types of metrics emitted. That is kind of what we did for our demo, where we augmented Jaeger's RPC metrics to actually have the trace ID information on it. So given a failure or a 5xx metrics, we know kind of what the success metric looks like. And yeah. So yeah, for a summary, we basically kind of showed you that trace differences can be really powerful to debug issues if you're able to find the right traces, and kind of using deep linking support between metric data points and traces, we can build a number of integrations that can speed up root cause. Finally, we kind of showed a sample of how this can look for an alerting engine or visualization tool like Grafana. So where can you actually get this? Like, where are we on this journey? The current end-to-end demo is actually is present at this link. There are a few changes which we've already made towards this, but there are many other kind of work in progress changes. We've also had help from the open source, from Grafana, like Bjorn from Grafana helped us add exemplar support in Prometheus client. And the actual change to kind of store exemplars in memory and then forwarding them onto remote write is still kind of a work in progress. Some other resources that are of interest is, like, if you've not checked it out, please do go check out kind of Rob's talk on deep linking metrics and traces that he gave at KubeCon San Diego. It kind of talks in more detail about how this deep linking is actually possible and kind of what are the technical challenges with that. And there are a few other resources here around OpenMetrics, OpenTelemetry, Prometheus M3, and Grafana. And finally, thank you so much. Thanks a lot, everybody. Thanks for your time. Do come stop by our virtual booth to sign up for demos, to check this demo out and the other interesting features we're actually building. Yeah, thank you.